For 3 years, the tech industry has operated on a simple premise. AI software grows perfectly, exponentially, and without physical friction. That belief was anchored by the METRAI AI capabilities graph. This specific chart is the primary evidence used in congressional briefings and investor decks to justify the idea that machine intelligence is doubling every few months. However, 3 independent critiques recently documented that this foundational graph is built on inconsistent baselines and tasks where the difficulty is conflated with simple duration. The metrics used to project infinite growth are essentially non-reproducible. This theoretical error is manifesting as a massive fiscal shock. Uber, for instance, exhausted its entire allocated AI budget for 2026 in the first 4 months of the year. When the primary chart used for policy decisions fails to match the actual burn rate of the world's largest apps, the era of frictionless software growth ends. We are seeing the transition from weightless code to the capital-heavy requirements of industrial infrastructure. At the individual level, productivity has surged. AI coding agents are enabling application developers to produce code at 10 times their previous speed. But the platform teams responsible for the pipelines that test and deploy that code have remained the same size. This creates deployment debt. Code is generated faster than the infrastructure can absorb it, resulting in fragile testing and weaker security. Productivity gains are only useful if systems can deploy them. If infrastructure can't handle the volume, increased speed becomes an organizational hazard. This pressure is already triggering major workforce shifts. Wix announced its largest ever layoff, cutting 1,000 jobs. AI tools can now perform that specific translation for free, making the company's traditional headcount redundant. These layoffs represent a structural shift. AI is beginning to eliminate entire industries that exist solely to make technology accessible to non-technical users. Beyond software bottlenecks, we are hitting the physical limits of the silicon currently running these models. Cerebras Systems recently went public with a $34 billion valuation, positioning itself as the first major industrial challenger to NVIDIA's hardware dominance. Standard hardware hundreds of small chips. The Cerebras wafer-scale engine uses a single massive piece of silicon, one monolithic wafer with 4 trillion transistors. By eliminating external networking, this architecture provides AI speeds 70 times faster than leading GPU alternatives. Winning the next phase of AI development requires mastering specialized silicon manufacturing at a scale that mirrors heavy industry. As these hardware requirements scale, the technology is transitioning from a commercial product into a state-controlled asset. The White House is finalizing a classified contract to give U.S. intelligence agencies access to Anthropic's Claude models. This deal is one piece of a $9 billion expansion in computing resources reserved exclusively for intelligence and surveillance operations. These models have moved beyond general productivity tools. They are now integrated components of national intelligence infrastructure. This consolidation of U.S. power is triggering a global push for digital independence. Norway is currently building its own sovereign large language model to ensure its domestic infrastructure does not rely on American providers. OpenAI is countering this by securing content partnerships with Brazil's largest media groups, marking its first major move to control training data in Latin America. AI has matured into an industrial contest. Future capability will be determined by the physical control of chips, the regional ownership of data, and the infrastructure of the state.